Hello and welcome to Open Channel Flow Coronavirus Edition. Okay? As you can see, this is your open channel test apparatus. Alright? There are three distinct sections of flow here. You have the flow before the sluice gate. This is the sluice gate. You have the flow after the sluice gate. And you also have the flow after the hydraulic jump. This guy right here is a hydraulic jump. It is a near discontinuity in flow in which the flow is allowed to rise in the direction of the free surface. In open channel, you have three fixed surfaces and one free. That is the one above the flow. Okay, so when you have turbulence or a near discontinuity, you should have a rise in the section of the free surface, in the direction of the free surface. Okay. So if you're familiar with closed pipe flow, you'll be familiar with a Reynolds number. Reynolds number decides whether or not the flow is turbulent, laminar, or in a transition region, right? So if it's above about 4,000, it'll be turbulent, and if it's below 2,100, it'll be laminar. If it's in between, it'll be in the sort of transition region where it can have values of either or laminar or turbulent. In the case of open channel flow, we have a Froude number, okay? So the Froude number allows us to predict the downstream condition, all right? So your critical Froude number is 1, so if it's above 1, then you know you will have a hydraulic jump or a near discontinuity in flow downstream. If it's below 1, then you won't have that downstream. So in this little section here, section 2 we'll call it, you will have a Froude number of greater than 1, okay? So in each state, you'll need to record a certain amount of data. You need to record the channel height, okay? You need to record the total pressure manometer height, which is the one on the inside of the glass. And you'll also need to record the static pressure height, okay? Now both the static and total pressure heights are taken from above the water line. We'll talk a little bit more about that later. It gets a little bit confusing. But effectively, what the static and total pressures allow you to do is find the dynamic pressure. The dynamic pressure allows you to find the velocity, which is needed to find the specific energy in each state and find the head loss, okay? So, since we have three sections of flow, we will have a head loss between states 1 and 2 and a head loss between states 2 and 3. We have both theoretical and experimental calculations that you're going to need to do to surmise a theoretical head loss and a experimentally determined head loss for the scenarios in this lab. Okay, I will go on to the equations next.